I've just built my highest Q coil system yet. So it consists of, essentially I've wound three Bifilar Tesla's Bifilar Pancake Coils. And so my signal source is this function generator here. So I'm on 3.510 with a 20 volt peak to peak sine wave. So into 50 ohm, that's 1 watt. Now the source, the transmitter, is literally coming across two of these coils. So I've got two of these coils in parallel, and it's literally going across both of them, and with the same rotation factor going on. And then I have this additional coil. So the ground side, the return side, so I've got my active and ground, also then connects to the outside of a third Bifilar Pancake Coil, and then its output is going out to the oscilloscope, which is probably about 1 mega ohm impedance. So this is obviously high impedance system, which most of my experiments are. Now I can adjust the tuning by moving this coil back and forth, but that's going to be tricky with one hand doing a video, but I can also tune it by moving a magnet. So we've got the 20 volt peak to peak input. At the moment the scope is on the 5 volt per division. Sorry about this poor viewing here. And you can see we've got 5, 10, 15, 20. So it's 20 volt peak to peak, like the input. Now I'm going to adjust the magnet. All right, I'll move the magnet along. Now you'll be quite amazed at just how high I get this, right? Oops, I'm gonna have to change from 10, I'll go to 20 volt per division, and I'll continue to adjust. Okay, whoa, let's see. I'll just line that up. So what we should have now is 20, 40, 60, 80, 100, 120, 140. Sometimes I can actually get a little higher than that, so probably haven't quite got that optimum. I can get to 150. It's very tricky though, but there you go. That'll do for the purpose of the video. So there's 140 volt peak to peak at the output. Now I have an interesting plan for something like this. What I was thinking is, I mean, this is great for creating high energy small antennas, but it'd be even better, of course, to be able to make use of such high voltages with a longer antenna. Now that's of course very difficult, because when you're using a much longer element, you get so many losses along the element, the reflections that you're trying to reuse and tune to resonance are less. So I have an idea where I'll literally have two of these, one each end, connected by coax. So coax feeding as the source to one of them, and then have another coaxial run sending the signal half a wave away to another one. But at each end, and they'll be connected, coupled of course by the coax shield as the ground side, but at each end of this half wave run will be, let's say, a torus element like this that I'm driving up my voltages to a really high peak. And same at the other end, but they'll be 180 degrees out of phase. So then essentially we've got these really high voltage oscillations going on the small elements at either end, which of course then will drive displacement currents along the coax shield as like a wave guide. So instead of conduction currents, would be displacement currents shooting back and forth between the two opposing super hot elements that are exceedingly high in voltage. So I'll get higher voltages at either end of that half-wave antenna than I would in a normal half-wave antenna system. That's my theory, or at least my hypothesis. 7.3, and thanks for watching. Isn't that fantastic though? That is extremely high peak-to-peak voltage, remembering that's on the 20 volt per division. So that is awesome. 7.3, and thanks for watching.